Hello everyone, today we will learn about the process formulation of shielded metal arc welding. The teaching objectives are as follows. First, understand the composition and identification of lower weld symbol. Second, learn the selection and preparation of the lower groove. Third, get to know the selection of its process parameters. Along them, the composition and identification of weld symbols and the selection of process parameters for shielded metal arc welding are the key contents of this section. First, we learn the composition and identification of the weld symbol. What is the weld symbol? In order to simplify the weld on the drawing, we use symbols to mark the weld form, weld and groove size, welding method, and other welding requirements. Such symbols are called weld symbols. Weld symbols are composed of basic symbols, supplementary symbols, dimension symbols, and leader lines. Basic symbol is a symbol representing the cross-sectional shape of the weld, which is similar to cross-sectional shape of the weld. Supplementary symbols are used to supplement some features of the weld. Dimension symbol is a symbol indicating the size of the weld groove and weld. Guideline consists of arrow line and two reference lines, one solid line and one dash line, and sometimes a tail symbol is added at the end of the horizontal line. How about their functions? The label on the solid line side of the reference line represents the shape and the size of the groove, and weld on the arrow pointed side, and the label on the dash side of the reference line refers to the shape and size of the groove, and weld seam on the other side. The welding method is marked by Arabic numerals at the end of the leader line. Here are some common welding method codes. The basic labeling method of the weld symbol is as follows. Basic symbols should be drawn in the middle of the baseline. Dimensions on the cross-section of the weld on the left of the basic symbol. The dimension in the length of the weld on the right of the basic symbol. Dimensions such as bevel angle, bevel face angle, root, clearance, etc. are marked on the upper or lower side of the basic symbol. Next, we learn the selection and preparation of the groove of the welding joint. What is a groove? According to the design or process requirements, the groove is a channel formed by processing the parts to be welded into a certain geometric shape and assembling them. Why should the welded joint be beveled? There are two main purposes. One is to ensure the arc can reach the root of the weld to penetrate it and obtain a good weld formation, which is convenient for slang removal. The other is to adjust the fusion ratio by alloy steel. The groove form to be adopted mainly depends on the form of the welded joint, the thickness of the workpiece, and the requirements for joint quality. The common groove forms of butt joints are I-shaped, V-shaped, X-shaped, U-shaped, and double U-shaped, etc. The geometric dimensions of the groove are mainly represented by the following parameters. Groove angle, alpha. Groove face angle, beta. Root gap, B, blunt edge, P, and root radius, R, ECT. There are many kinds of groove processing methods. The specific processing method should be selected according to the size and the shape of weldment and the processing conditions of the production site. Common groove processing methods are as follows. Shearing. For the I-shaped groove of the thinner steel plate, the shearing machine can be used to cut the edge. Beveling. Any bevels can be machined from straight edges with a planer or bevel. Turning. The edge grooves of an annual part such as pipes can be done by turning. Milling. Beveling the edges of sheets or pipes with a milling machine. And gas cutting, a widely used method which can process V-shaped and X-shaped grooves at any angle except U-shaped grooves. Finally, let's learn the selection of shielded metal arc welding process parameters. The parameters include electrode diameter, welding current, arc voltage, welded welding speed, and welding layers, etc. Whether the selection of welding process parameters is appropriate or not directly affects the shape, size, welding quality, and productivity. Therefore, choosing the appropriate welding process parameters is an important task that cannot be ignored in welding production. First, let's look at the choice of electrode diameters. It refers to the diameter of welding core, and the selection of the diameter of the electrode is an important factor to ensure welding quality and efficiency. The diameter of the electrode is usually selected according to the thickness of the workpiece. Here is the reference table. Of course, for the specific selection, we should consider factors such as joint form, welding position, and welding layer number, and for important structures, the requirement of welding heat input also matter. Under the condition of the same plate thickness, the diameter of the electrode for the flat welding position should be larger than that of the other positions, and the thinner electrode should be selected for vertical welding, horizontal welding, and overhead welding, generally not exceeding 4 mm. Next is the main parameter, the selection of welding current. The size of the selected current mainly depends on the diameter of the electrode. Here is the recommended value for reference. Of course, the selection of the current size is also related to the thickness of the workpiece, the form of the joint, the welding position, and on the site use. For thin workpieces, position of vertical welding, horizontal welding, or overhead welding, and welding with alkaline electrodes, the welding current should be appropriately reduced. During welding, the arc voltage mainly depends on the arc length. Generally, the arc length is controlled between 1 and 4 mm, and the corresponding arc voltage is between 16 and 25 volts. In the welding process, short arc welding should be used as much as possible. In vertical welding and overhead welding, the arc length should be shortened than in flat welding to facilitate droplet transfer and prevent molten metal from dripping down. The arc length of the alkaline electrode should be shorter than that of the acid electrode in order to stabilize the arc and prevent generation of pores. During the welding process, the welding speed should be uniform and stable. If the speed is too fast, it is easy to cause defects such as lack of fusion and poor weld formation. If too slow, the width of the heat effects zone will increase. The grinds of the welding point will become coarse, the mechanical properties will be reduced, and the deformation of the workpiece will increase. In addition, when welding thin workpieces, it is easy to cause burn through if the welding speed is too slow. Therefore, during the welding process, the welding speed should be selected appropriately for the penetration. No burn through the weld size as required. When welding thick workpieces, multi-layer welding is often required. The selection of numbers of welding layers is mainly based on the thickness of the steel plate, the diameters of the electrodes, the groove type, and the assembling gap, which can be approximated, that is, the thickness of the plate divided by the diameter of the electrode is almost the number of layers to be welded. Okay, that's all for this class. Thank you.